Hey guys, in this video tutorial we are going to see arrays and array operations. We all know that arrays are the most basic data structures in any programming language. They are linear data structures. They store data, but the data should be of one data type, which means if you have numbers and characters, then an array can store only one of them. They store data at contiguous memory locations, which means any arbitrary element in an array is connected to its previous and next element. Now we are going to see some array operations. Our array ARR with 7 elements, and the size of array is given by int size. Now this size of operator or keyword is used to get size of any variable or data type, which means we are getting size of whole array here, and we are dividing it with the size of just one element of array so that we can get how many elements are present in array and which will be stored in size variable. Now let's first discuss the array operation array traversal. We will pass array and size to this function to get all the elements printed. Now we will write the function definition. So first we write data type which a function should return. So we'll write it as void because we have to print all the elements and not return anything. We'll write function name traversal, and we will pass formal parameter array and s for size. Now we will run our for loop. So this hashtag define keyword, we have made our for loop. We will simply run our for loop iterative variable I 0 to s. We will print the element, and we don't have to go to next line, we have to just put a space. Now I think it's all good. We'll run our function, and yeah, we have got the output. Now let's discuss the further operation, which is sum of all the elements in array. We have to print sum of all the elements in an array. So we will write the data type of function. Sum will be integer, so we have to write the return type integer. Sum ARR function will write, in which we will pass a formal parameter ARR and in size of array. So we will write this sum variable is equal to 0, which we have to increment, and we'll write the same for loop I comma 0 comma s, and we'll say sum plus equal to ARR of I, and after the execution of for loop is completed, we'll return sum. Sum ARR here, and size also we have to pass. We'll comment this and run our code to see what's output. Let's see if our array elements give some 28. 5 plus 2 7 plus 7 14 plus 4 18 plus 3 21 plus 6 27 and 28. Fantastic. Our function has given correct answer. Now let's discuss the third function, which is to search an element in array. So we'll pass array size, and let's suppose we have to search an element 2 in array. We'll write function definition. It will be void function, as we have to only print index at which the element is present. So we'll write ARR formal parameter int ss size again, and int x as a formal parameter for the element 2. Again we will run for loop I 0 to s, and we will write a if statement inside it, and we will say ARR of I is equal to x. Then we have to print index at which the element is present and break the loop. So that's it. This is the function definition. We will run the code. It has given answer 1, 2 is present at index 1. Our code has given correct answer. Now let's tackle some other operations. The fourth operation we are going to see is reverse of an array. We can simply print reverse of an array by using a simple for loop. But if you wish to make changes in actual arrangement of array, then we have to use some algorithm. Here is the pseudocode of the algorithm. First step, we will take 2 pointers. The left pointer will point to the element present at 0th index, that is first element, and the right pointer will point to the element present at last index. In the second step, we will say while left is less than right, swap ARR of left, ARR of right, which will swap elements which are present at relative locations. We will simply say left plus plus and right minus minus, and our while loop will run till left is less than right. We will understand this with the help of an example. Here is the example in which we have given an array of 4 elements 1, 2, 3, 4. So according to our pseudocode, the left pointer will be here and right pointer will be here at first. Then in the second step, we will swap 1 and 4 as left pointer is less than right pointer. So we can see that 1 and 4 got swapped, and we will increment the left pointer and decrement the right pointer here. In the next step, we will swap 2 and 3 also. So you can see that 2 and 3 got swapped. So this is our answer. We will see one next solution which contains odd number of element 2, 5, 3, 7, 6. So we will do the same. Left pointer here, right pointer here, and we will swap the element 6 and 2. They got swapped. Then we will increment the left pointer, we will increment the right pointer, and we will swap 5 and 7. Now the left pointer and right pointer will be here. So the condition for our for loop will get violated and 3 is going nowhere. So this is our answer. Let's see the code for the same, and we are going to write code for the reverse of array. So we will take void return type. We will say reverse. We are going to pass our array and the int s, which we usually use for the size of array. We will take 2 pointers, left is equal to 0 and int right is equal to s minus 1, which will point to the last element of array. We will run while, as we have seen in the pseudocode, left is less than right, and we will say swap ARR of left, ARR of right, and we will do left plus plus and right minus minus. But we don't have a code for this swap function. We will write this also, write the same void swap. Here we are going to use the pass by reference method, int ampersand x comma int ampersand y, and we will write int temp is equal to x is equal to y, and y is equal to temp. This is our function. We will run it. Reverse, we will pass our array size, and we have to print the elements of array, and we have to see whether the array got reversed or not. So we will write a for loop for the same array for int I belonging to array ARR cout I, and we will just space separate it. Okay, we will run our code now. And yes, we have got the output. The array here got reversed. There is one recursive method for the reverse of array, which we are going to see also. We'll write the name reverse recursive, and we will slightly change the way we take arguments. So we will take int arr same, and we will take the pointers which we have taken in the previous one as arguments. So we will write the function to swap the elements which we have written here. We will write int temp is equal to arr of left, and arr of left is equal to arr of right, and we will simply say arr of right is equal to 10, and below that we will call reverse recursive function recursively, which will take the same array, but this time left plus 1 comma right minus 1, and according to rule we have to write one base condition in a recursive function. So the base condition here will be left greater than equal to right. So in that case we will simply return. So this is our code. We will comment out this code and we will write reverse recursive. We will pass array, but in the left we have to put 0 as starting index, and in the right we have to put size minus 1 as the top index of array. Here is our function. We will run. We have got the same output. Now let's discuss about time complexities of all the functions we have seen till now. The first function is traversal function. The time complexity of this function is big theta of n, as we have to traverse the entire array and see each element. The same for sum of all the array elements. We have to go through all the array elements and take the sum. The search function will have big O of n time complexity, because element we want can be found anywhere in the array or not. Swap function has constant time complexity big O of 1. The reverse function we have seen has time complexity big O of n by 2, which is asymptotically equal to big O of n. It is true for iterative reverse function and recursive reverse function.